When enterprise AI projects stall before production, the root cause is rarely the language model. The failure point is almost always the data pipeline, brittle infrastructure collapsing under the weight of sudden scale. Researchers at Meta.ai recently diagnosed this exact problem in a paper introducing NeuralSet, a framework that exposes the specific structural flaws embedded in legacy data pipelines. Surviving the leap from pilot to production requires dismantling 4 specific architectural traps that currently bottleneck enterprise AI. The first trap is called eager loading. Attempting to cram massive raw datasets entirely into RAM leads to catastrophic memory failures the moment a project scales up. NeuralSet solves this through structured data decoupling. The system processes lightweight metadata lazily, keeping it separated from heavy data extraction until the exact moment compute is required. The second trap is the fragmented silo effect. Data teams waste weeks hand-stitching separate pre-processing tools for text, audio, and tabular data. This matrix shows capability gaps in legacy tools. Empty circles indicate where legacy software fails to support various data types. Scaling multimodal AI requires a back-end agnostic interface. NeuralSet fills every gap natively, funneling all data into a unified output. Without decoupled logic and unified interfaces, processing multimodal AI at scale demands physically impossible levels of manual data wrangling. The third trap involves untracked pre-processing parameters. A single hidden variable can cause irreproducible late-stage pipeline failures hours into a model run. The solution is deterministic caching. Every stage of a pipeline is tethered exactly to its specific parameters, ensuring that updates recalculate only the required dependencies. The final trap is the laptop-to-production rewrite. Velocity drops to 0 when local code built by data scientists must be entirely rewritten by engineers to run on cloud clusters. Hardware abstraction separates the compute infrastructure from the data logic. This allows developers to scale local code to a high-performance cluster via a single configuration flag. Perfect computational provenance and zero rewrite scaling transform brittle local code into resilient, instant-scale infrastructure. Long-term enterprise AI advantage does not come from renting a better base model. It comes from owning an orchestrated, unbreakable data pipeline. Audit your internal teams with one specific question. If our dataset grows 100 times larger tomorrow, does the code require a rewrite to run on a cluster? If the answer is yes, model development must be paused until your infrastructure abstraction is repaired.